Hello friends! There were no reviews on my channel dedicated to power supply units, but in this video we will test 3 devices with the most popular voltages of 12, 24 and 36 volts. According to the manufacturer, the first device should provide 12 volts and 8 amps, while the second one is designed for 24 volts and 4 amps. And the third device is the most powerful one. It should provide 36 volts and 5 amps. Visually, the first two devices are very similar, and moreover, they should provide the same power output. So the power output of 12 volts and 8 amps is equal to 24 volts and 4 amps. And according to the manufacturer, both devices have the power output of 100 watts. As to the third device, it's a bit bigger, and its power output amounts to 180 watts. As to the dimensions, 10.5 centimeters, 5.8 centimeters, 3 centimeters, 11.5 centimeters, 6.6 centimeters, 3.6 centimeters. 12 volt device, approximately 140 grams, 24 volt device, approximately 145 grams, 36 volt device, approximately 200 grams. Let's connect each of them to the power source and test their real specifications. First of all, let's test the most powerful device. 36 volts, 5 amps. As to the rest devices, here we have input voltage, input amperage, output voltage, output amperage. Also, the oscilloscope is connected to the output of the power supply unit. Here we have two bulbs, 36 volts, 36 volts. Each bulb consumes 60 watts. After their connection here, we will apply additional load of two 24 volt bulbs connected in parallel. Let's turn the power supply on. Here we have the output voltage, and here we can see the pulsing. The frequency is 178 Hz, and the voltage peak to peak amounts to approximately 0.1 volts. Let's apply the first load. So the pulsing changed. Let's check the efficiency. .97. Excellent. The second load.
So voltage peak to peak 0.07, 0.08. Not bad.
Efficiency. .93. Let's increase the load. Here we have 3.3 amps, and now let's increase the load gradually. .4 amps. The output voltage is stable. The pulsing is okay. .5 amps. .5 amps. The voltage peak to peak amounts to 0.08. The output voltage is stable, but let's increase the load a bit more. .5 amps. The output voltage is okay. Here the voltage peak to peak amounts to 0.1, 0.12 volts. Not bad. .6 amps. The output voltage is stable. And here the voltage peak to peak amounts to 0.13 volts. Let's increase the load. 6.5 amps. Here the pulsing is dancing and the output voltage is unstable. Let's increase a bit more. 6.8 amps. Here the waveform is bad and the output voltage is less than even 35 volts. Let's see the thermal image. So the maximum temperature amounts to approximately 70 degrees. So this power supply can really provide 5 amps and within the short period of time even 6 amps. Now let's test another one. 24 volts, 4 amps. Let's turn it on. The output voltage amounts to 24.4 volts. Here we have the pulsing. 0.06, 0.07 volts. Let's apply the first load. The pulsing waveform changed. The efficiency. .93. Let's increase the load. The waveform is more or less okay. .91. Let's increase the load. .3 amps. .5 amps. 4 amps. Here the voltage peak to peak amounts to 0.07, 0.08 volts. The output voltage is stable. Let's increase the load. 4.4, 4.5 amps, 4.8 amps, 5 amps, 5.2 amps. So 5.2 amps is the current limit for this device. As to the thermal image, the maximum temperature amounts to 63 degrees. So this device can withstand the load of 4 amps without any problem. And now let's check the third device. 12 volts, 8 amps. But for this test, these two bulbs will have insufficient load. Let's change them. Now here we have two 12-volt bulbs, each of which consumes 40 watts. Let's turn the power supply on. The output voltage amounts to 12.2 volts. Here we see the pulsing. The voltage peak to peak amounts to 0.06, 0.07 volts. Let's apply the first load. The waveform changed. As to the efficiency, .93. Let's increase the load. The voltage peak to peak amounts to 0.09, 0.10 volts. The output voltage amounts to 12.2, 12.1 volts. As to the efficiency, .87. Now let's apply the third load. The output voltage amounts to 12.1 volts. The output amperage amounts to 7 amps. .5 amps. The output voltage is stable. 8 amps. The output voltage is OK. Here the voltage peak to peak amounts to 0.08, 0.10 volts. Let's increase the current. .3 amps, 8.5 amps, 8.7 amps, 8.8 amps, 9 amps. The output voltage amounts to 12.1 volts. So there is no possibility to increase the load here, and let's change one of these bulbs. .5 amps, 8.2 amps, 8.6 amps, 8.9 amps, 9.4 amps, 9.6 amps, 9.6 amps. As to the thermal image, the maximum temperature amounts to 74 degrees. So the peak amperage of this device amounts to approximately 9.5 amps. Now about the conclusions. Each of these three devices copes with its task. The output voltage is very stable, though it's not precise. So the devices don't provide exactly 12 volts, 24 volts and 36 volts correspondingly. As to the power output of the devices, it's even higher than the wattage mentioned in their specifications. Hope this video was helpful for you. Thanks for watching. Wish you good luck.